Good afternoon and welcome to the webcast on why area relay coordination in ASPEN one-liner. I'm your presenter, I'm Sherman Chan. Many of you know me. And right now there are 27 of you are watching. And so good morning or good afternoon to all of you. I want to first mention that this webcast is going to schedule to last an hour, and I'll be talking most of the hour, but the last 5 minutes I will open it to questions and answers. You will not be able to ask me questions during the presentation because I have turned your mic off. So you have to be patient to the end. And also I want to mention that this webinar is on something that we haven't released in the program yet. And this is not a common practice. We usually show you things that we already released. But this topic is so important that I felt compelled to tell you about it in advance, with the hope that you will give me some feedback to see if I'm on the right track. And also I will be looking for volunteers at the end to help test the program before it's released in the new year. So I will show you a timeline also at the end of this webcast on about when you will receive new programs for with these features. Okay, let me start with this question. Now, why is wide area relay coordination important? Well, it's important for at least two reasons. One is that the fact that relay coordination and doing it right, it's part of almost every one-liner user's job description. And secondly, the recent PRC 027 standard requires the utility to have a systematic way of checking relay coordination every 6 years and also whenever there's a change in your system. So in order to have a systematic way of checking relay coordinations, to me that means that we have to have some tools, should design some tools that allow you to do that. So to begin, I want to first show you the commands that we currently have in the program for checking relay coordinations. And I want to let you know that these commands are going to stay. We're not throwing these commands away, but we are going to be making new ones, new and improved versions of these commands. Okay, the first one I want to mention is the command that checks the overcurrents minimum pickup to make sure the purpose is to make sure that the relay is sensitive enough to pick up on first, a remote bus fault with and without branch outages that are behind the relay. And secondly, the relay will trip on remote line end faults. So here's a picture of what I'm talking about. The relay that I'm concerning about is right where I'm pointing on the left-hand side near bus A. And so the first check is to put a fault at the remote bus B, and see if the relay picks up. And also the program will be out, the program outages these branches behind the relay, make sure that when you fault bus B, the relay will still pick up. And then on the second picture on the bottom, the same relay, we want to make sure that it will trip on remote line end faults. Okay, so there's also another command for checking overcurrent relays, and that's called check OC instantaneous. What it does is they're listed in this 1, 2, 3, and 4. First, it says it should trip on a close-in fault. Okay, I think that goes on without saying because it's instantaneous. So better trip on the fault right in front of the relay. The 2, 3, and 4 are all on things that it should not trip on. Number 2 says it should not trip on a remote bus fault with or without outages of the branches at the far end of the line. And number 3 says it should not trip on a remote bus fault with mutually coupled lines, outage and grounded. Now this is an option because in a lot of utilities, they do not ground the lines that are outaged. So this would not be something that you care about. So number 4, it says it should not trip on the line and fall of a parallel line. So let me show you a picture of what I'm talking about. So the top picture is what the relay should trip on, and that's a fault right in front of the relay. The second picture says it shouldn't trip on a fault at the remote bus with or without outages of those branches just to the right of this bus. And finally, for lines that have parallel lines that are mutually coupled, the relay puts a line and fault on that parallel line and makes sure this relay does not, the instantaneous in this relay, does not think that the fault is somewhere over here near the end of the line. So those are the things that the check instantaneous. And finally, there's the third command, and the third command checks the coordination between a pair of relay groups. And this command requires that user specify primary backup pairs. In other words, you have to designate one primary relay group, and then from that you choose the other backups to it. And at the same time, the primary may be backup to something else. So it's a complex web of relationships between primary and backup that you have to set up manually. And this can be tedious. And what, in a nutshell, what one-liner does is that it simulates, it will look at these pairs one at a time, and then each pair, it simulates faults in front of the primary relay with and without outages. And then check the coordinating time interval between the primary relay and the backup relay. And we'll warn you if the CTI is too high or too low. So this is the third command. Now, if you think about it to look at it from a far perspective, there are basically two kinds of commands. One is the command that kind of checks the settings of the relay to see they're reasonable. So those are like the one that checks the pickup of the overcurrent relay and also checks the instantaneous. And then there's the second kind, which is that checks the coordination between pairs of relays. So we will, in the new command, we will follow the same architecture, but there's something that very new about the new commands. So I'm going to now start telling you about the new commands. Okay, the first new one, and actually a few new functions, I should say, is the relay checking function for overcurrent minimum pickup. So the algorithm will exactly be the same as before, except we will make the checking of relay pickup on remote line and faults an option that you can turn it on and off. The reason for that is that in transmission systems, oftentimes the relays have duplicate backups. And so if one doesn't work, the second one would likely to take over. So the need for it to check whether the relay is sensitive to pick up on line and fault may not be as important to you as it was before. Now in lower voltage system, this might be important, but in high voltage, there's still some overcurrent ground relays in use, for example. But people may not care that whether it will trip on line ends on the remote line. So we made an option now that you can turn this on or off. The relay checking command for overcurrent instantaneous is also more or less the same as before in terms of the algorithm. But what is new about the new command is not only that we tell you whether it not trip on the remote bus fault and trips on a closing fault and so on. the new command will actually tell you exactly how far of the line, how much of the line is actually covered by the instantaneous unit. For example, it would tell you it would cover all the way from in front of the relay to 30% of the line, for example. And now, well, one thing that you might already have thought of when I was describing the existing commands, and how come there are nothing there for checking distance relays? Well, we're going to make that up in this new version. The new program, the new command will check distance zone 1 and zone 2 reaches. So this slide is about zone 1. Okay, so the new command will check distance relay zone 1 reach and tell you how much of the line is actually covered by zone 1. So let's say you want the zone 1 to cover 80 to 90% of the line, and the program finds it only covering 70. Well, it would give you a warning that you're not between the 80 and 90 limit that you have set. And optionally, the program will check the ground relay zone 1 reach with neutral lines, outage and grounded. Well, it's well known that when you have neutral lines, outage and grounded, they would affect even the zone 1 reach of the line. So this is maybe important if your utility has this practice of grounding lines that are taken out of service. Okay, and this slide is about checking distance relay zone 2. Okay, of course, the zone 2 should cover part of each of the remote lines, and also it's also important. I'm not looking at I'm not describing the stuff on the slides right now, but just in general, the principle is that the zone 2 should cover part of the remote line, but it shouldn't cover too much of it, such that the zone 2 would start infringing on the remote line zone 2. So now they've got zone 2 racing with each other. Okay, so the program will do these following checks, and each one it would find out how far the relay reaches on a remote line. So the first option, the first scenario with my mouse pointing, is with no outage of any kind. And on number 2, it would check the reach, how far zone 2, when it outage all the other infeeds except the line that you're looking at, the remote line that you're looking at. It would outage other remote lines to see how far zone 2 will go. Okay, this is bound to go a lot further than you would normally see it in case there are multiple lines connected to that bus. Now, the following are optional. It would also check, we will outage the infeeds one at a time and check the reach of the zone 2. And if you mark the one that says double contingencies, the program will also outage 2 infeeds one at a time and check the reach of the reach of the zone 2. So here's an example of what I'm talking about. So let's say here's the relay on the left, and on the remote bus there are 4 lines that are going out of the left. Okay, suppose that the top line, line 1, is the one that I'm studying. In other words, I want to see how far this relay is going to cover on part of line 1. So in case 1, right here, I consider no outages. So I would say, okay, well, it covers 10% of line 1. Okay, and then it's case number 2. It would outage all the other infeeds. Oh, okay, I found my mouse again. And meaning that in this case, it would outage lines 2, 3, and 4 simultaneously. And then it would tell me, oh, now the zone 2 covers 60% of the line. Okay, okay, that's fine. And then in case 3, 4, and 5, it would outage the line 2, and then it outage line 3, and then outage line 4, and each time you look for the reach of the zone 2. And then if you ask for double contingencies, it would consider 3 cases, one with outage 2 and 3, one with 2 and 4, and one with 3 and 4. In other words, all two line combinations of the remaining remote lines. So there's a lot of cases over here. And if you don't care about cases 3 through 7, there's a way to turn that off. Okay, so what would this check typically tell you? It would, number one, is that it would tell you exactly how far the remote line zone 2 will cover. Now, I should stress that this, and it also the same comments applies to the checking of the instantaneous unit. The program always, whenever it tells you how far it covers on a certain line, it actually does it by fault simulations and not by looking at the parameters of the setting. So in other words, to look for the zone 2's coverage on the remote line, we will actually simulate many faults on the remote line and then see where the transition between zone 1 and zone 2 and zone 3 happens. So this is done with lots of fault simulations, but the program is really fast. So hopefully this can do the job much faster. And I know it would be a lot faster than if you were doing it by hand, certainly. Okay, and here, back to here, now item number 2 will warn you if the coverage is too little. Now, some people may or may not care how far the zone 2 will go. If you don't care, you just say the limit is 0, and it won't warn you. But if you do care, and you can put like 5%, so if the coverage is less than 5%, it will warn you. So it's all up to you. Number 3, it will warn you if the end of zone 2 is too close to the remote line zone 2. So you can set a limit. Say, well, if the two are within 5% of each other, and then tell me about this. And number 4, certainly, the program would give you a big error message if the zone 2 overlaps the remote lines zone 2. And really, that is the main purpose of this zone 2 checking, to make sure that two zone 2s don't overlap each other. Okay, now let me tell you the new checking command that are designed to check pairs of relay groups. And first of all, I shouldn't say pairs of relay groups. I should say that the command is used to check whether your relay settings are any good in protecting the lines in question. And the big item at the beginning says it does not require primary backup pairs. Okay, so this is going to be the big selling point, because this will work without you having to go around establishing these primary backup pairs. And secondly, the relay coordination is done with stepped event analysis, with faults along the study line as initiating events. Now, I use the term study line as the line where the relay that you highlighted and the line of interest. That's the zone 1 line. And so you would highlight a relay on the zone 1 and say, well, put a fault at these percentages and tell me whether they get clear in the certain amount of time. So that's how this works. Now the simulation can also run with or without outages at the two ends of the line. And you can specify these to be single or double outages. And double outages could actually include cases that where one line is on one end, another line is on the other end. It would actually find all possible combinations of these double contingencies if you want. So that's what I just said is what is here is in the first bullet. And in the second bullet, the report would tell you whether the fault was cleared by the breakers at the two ends of the line. Well, so that's really the ultimate test, isn't it? If you put a fault on the line, you wanted it to be cleared. Now, what are the common problems the program would find out? The first one is that other relays, other branches may trip out before the study line is cleared. Well, this happens. It takes too long to clear the fault. In other words, eventually the line is closed by clear, but it might take way too long for your taste. And number 3, the fault is not clear after 4 events. Well, it shouldn't take, if everything is working properly, it shouldn't take more than 2 events to clear the line. You know, you can open the end on one end and open the fault at the other end, and the fault should go away. So if it takes more than 4 events and it's still, the fault is still around, the program would just stop. And you know, this is just a time-saving feature. Okay, so now this is the part that's really surprising, that I actually didn't think of this until I was getting in the midst of working on this. The method will give you for each of the 2 relays at the 2 ends of the line, just before the program decided to trip them. The program look around and find out what is the next fastest relay that would have tripped if this relay isn't working. Well, the CTI is exact. That would tell us the CTI information, because that time difference is the time, the coordinating time interval. So the program, before each one of the 2 relays on the 2 ends of the study line trips, it would find out the next fastest relay, and it would give you in the report the name and location of that backup relay. Okay, and that's very telling, because that tells you if that relay hadn't worked, which other relay would have worked. And if that relay is too far away or is not the one that you have in mind, well, that's something that you should take a closer look. Now, this slide is talking about something that applies to, that affects all the new commands. And this is a new option to outage to the 3 strongest sources only. And what it means is that prior to checking the relay settings and relay coordination, the program automatically simulates a 3-phase and a single line to ground for each end of the study line, and then sort the branches at each end in descending order, the magnitude of the current flow in the 3-line to ground case. In other words, you want to put the strongest source first with the highest current first, and then the one that has the least amount of current flowing to that bus on the bottom. And then on number 3 here, it says branches with 0 flows in both the 3-line to ground and single line to ground case are excluded, because these branches are clearly just a stub that go into somewhere with no source behind it. So why outage that? I mean, it's just wasting time. So this is put into the program and to help reduce the time that it takes to do it. Okay, so before I show you the program, I want to a little timeline on what we are going to do. From now to the end of this year, we're going to continue in-house testing. As you can see in a few minutes, the program is already working. But a little more testing couldn't hurt it. And also, we're continuing to get ideas from people, and hopefully also from you guys. And we will tweak the program between now and then. And then the second bullet says from January 1st to the day after Valentine's Day, we're going to send the program to the volunteers. Those of you who, I think we already have about 8 volunteers from yesterday. So if any of you wanted to test this program and give me feedback, you can do that for a month and a half starting in the new year. So on March 1st, we plan on releasing version 14.5. That's the next maintenance release with the new relay checking and relay coordination checking commands. And also the power script function for those commands will also be released. So those of you who want to write your own batch programs, you can do that. Now, in 2 months from there, we plan to release regular commands that will do batch checking. I should back up one step and tell you that the commands currently only does one line at a time. And this is done for a reason, because when you're trying to walk, you want to do baby steps first. You don't want to take a big leap and then fall on your face. So our strategy is to make the commands to work on one line at a time. And then when everything looks like they are working, then we'll release a batch command and say, well, we'll check every line in this area, in that zone, in the vicinity of somewhere. So all that will be available on May 1st. And also, some later on in next year, an enhanced version of this command for 3 terminal lines will be released. Now, to make this possible, I want to bring to your attention that in version 14, there's a new tap bus status for buses that are at the middle of 3 terminal lines. So I suggest that if you have extra time, go around your system and mark those middle buses with this new tag, so that it's not a tag, I shouldn't use the word tag, but a flag, so that when we start checking 3 terminal lines, we will know where to look for, a sure way to look for them. And no, I'm not going to show you the end slide yet, because it's not the end. I'm going to show you actually how these commands work in a sample system. So bear with me for a minute. So I'll close this program. Okay, so here's the 30 bus system that all of you know. And I have tweaked it a little bit to just make it interesting. The line that I will be looking at is this one that in the middle of near the middle of the screen that I just highlighted. And it's one end of it's Vermont, 33 kV, and the other end is Oregon, 33 kV. Obviously a very long line. So I'm going to ask the program to check these, okay? In your current version 14.4 program, if you click on the check, there are 2 commands over here that are grayed out. Yeah, right now they're also grayed out on mine because I haven't highlighted a relay group. So these are the 2 commands that I'm going to make work. I will make them work in the 14.5 when it's eventually released. But I'm going to demonstrate that to you right now. Okay, so on the left-hand side of this line, there's this relay group near Vermont. It has a distance ground relay, an overcurrent ground relay, and an overcurrent phase relay, just for the fun of it. And on this end of the line, there's a distance ground relay and overcurrent ground relay. Before I actually even show you this new command, I want to show you something about a new feature called the time distance diagram. It was made available in version 14. So if I highlight this relay group and say view time distance diagram, I will see something like this. Okay, so this is Vermont, and here's Oregon. So this is the line that I'm working on, and this is a line on the Oregon end. It goes to a tap bus, and then it goes to New Hampshire. Okay. So I could select some relay over here by double clicking on it. So I could select the overcurrent ground relay, for example. And I could then click on the empty space and say show time distance curve. And you see a curve that looks like this. The horizontal axis, which is right here, it's the distance, okay, between Vermont and Oregon. And the vertical axis is time. Right now it's in seconds, although they could be in cycles. The curve may look kind of unfamiliar to you because this is a linear scale. You see, here's 1 second, 2 seconds, 3 seconds, 4 seconds. Because it's linear scale, it's not a logarithmic scale. And And there's also in this diagram an option called slider that you can move around. And on the bottom, when you have a slider on the bottom, it tells you how far you are from the left extreme of this axis, which is Vermont. And on the top, it shows you how many ohms there are. And also where in the sector curve, it tells you the time. And if it's a distance relay, it will tell you which zone it is. Okay, so you can move this around. So in this case, you can see that I got a ground relay. It goes to, well, I happen to know that this line is 100 miles long. So right here, it's about 33% or so is covered by the instantaneous. And then at this point, the time element kicks in. And then what you see here is the time element, okay? So you say, well, it's all fine on the top of the picture, but what's down over here, okay, on the bottom? Well, the bottom is actually for relays looking at the opposite direction. So for example, I can double click here and select another ground relay. And when I show the time distance diagram again, you can see that this one, this one it goes downward. You see that because the time axis actually goes up as it goes, when you move in the down direction. So it takes a little getting used to if you haven't seen this kind of picture. But so this is the way that you can visualize this. So if I had chosen a distance relay instead of I'm sorry, I should have right click on it and tell it that I want to change the relay that I want to look at. I select ground relay here, and I will right click on here and tell it I want to change to a ground relay. Now when I show the time again, you can see that there's a relay to zone 1. See, it tells you zone 1 and zone 2 and then zone 3. Now I can also bring in this relay in one of these remote lines. And now when I show it, you can see that this is the curve of the second line. Now none of this is set very properly for two reasons. One is that I'm not an expert in setting relays. And secondly, it's because I purposely introduced some weird stuff in here so that the program would actually show me all the error messages. So here you can see that there's a problem right away because zone 1 only starts at about 60% of the line, when it should probably start back over here about 80 and 90. The same thing with this one. It actually, because this is a tap bus, it should actually start the zone 1 way back here. And the other thing is that this zone 2 ends at a point where it's very close to the onset of zone 2 that's over here. So this gap between here and here is not wide enough for most people's preference. So there's a lot of interesting things here that's worth noting. So when I check these, I get lots of error messages. So the reason I want to show you these is, well, one is to just take this opportunity to show you something you may not have seen before. And secondly, it actually somewhat, it's a powerful tool that complements what I'm about to show you in the other command. Okay, so if I go back to this line, right now, as I said, these two commands only work on one line at a time. So, and the way that it works is you have to right click on the relay group and then go down here and then say check relay settings. So here's a dialog box. It may be a little bit hard to see. I don't know. You can see that over here it has a checkbox for overcurrent ground relay, overcurrent phase, distance, and distance phase. So you can choose one or more of these. And down here, the bunch of commands, options that are related to outages. The first one says outage lines only. Second one says outage only the 3 strongest sources. The third one says simulate double line outages. And the last one says outage and ground ends of mutually coupled lines. And this last checkbox down here says outage warning and errors only. So in other words, you only want to see the things that have problems, but not the stuff that are fine. Now I want to show you this command called checking parameters, because we're hiding a lot of the things back in this part here. Now I know this is hard to read, but I will only explain to you the functionality of these, and I won't go into them in great detail. The top box, which I'm pointing, is it contains the parameters for checking the relay coordination using step events. So the first one is actually the most important. In here, I type in 10, 50, and 90. That means that I want to study the faults at 10%, 50%, and 90% as the initiating events. Okay, so that's what it does. And then the other things over here, the minimum, maximum CTI, and some other things that I'm not going to go into at this time. And then the next box over here in the middle of the dialog box is for the parameters for checking the zone 1 of distance relay and checking the instantaneous units of overcurrent relays. And these are limits on reaches of zone 1. And they say, well, why are there so many things in this box? Well, that's because for the ground relays, we have one set of limits for lines that have mutually coupled, and then there was a second set of limits when the line is not mutually coupled. And so there's a lot of different options. So it's also, there's one set for distance relay and there's one set for overcurrent relays. And then finally, in the bottom part of this dialog box is a box that has the parameters for checking zone 2 and overcurrent time elements. And again, these are the limits for how far the relays should reach, and the zone 2 should reach into the remote lines, and how close the zone 2s can be, and that kind of thing. And on the bottom, there are a couple options. It says checking overcurrent relay line end fault, yes or no. So you can turn some of these things off also with this box. Now, we already envisioned the problem of you having to transmit this information from one user to another in the same company. So we have these two buttons over here. One is called store. When you press this, it would store the stuff in the XML file. And right now it's a text file, but we're going to use XML when we ship it. And then the person receiving this can just press the recall button and specify the file name, and the program would automatically copy these to this person's computer. So this way you can get everybody in the company on the same page in terms of what to check for. So this is the dialog box. Okay, well, so much for this. So I'm going to just go ahead and press this button to basically it will check the relay settings, both overcurrent and relay and distance on this line. First, it will do this relay group, and then it will do this relay group. Okay, and the first thing, the program asked me the name of a file where it can store the output to. The program now outputs everything in the CSV format, which is, I think, is the easiest for the people to programmatically parse these and look for problems and so on. And also, it's easy to get them lined up because Excel does the job for us. We don't have to figure that out. And also, when we do multiple lines in the future, we plan to put the results of each checking into a separate folder, so that if you check 1,000 lines, there'll be 1,000 different files, one for each one. So that actually somewhat compartmentalizes the results and make it easier for you to look for what you wanted to see. So for here, I just specify a file. And so now the TTY window, which is showing now, it only tells me what's going on. It doesn't actually have any results. So we did that so that the program is working and it hasn't gone to sleep. So that way you can go have your coffee and go to lunch and come back to see this result over here. So the result is in this CSV file, and the program has opened it with Excel on my computer. So let me just explain a little bit about what it's showing you right here. Give me a minute to. Okay, so here you notice that there's the very beginning of this file is just tells you today's date, the name of the file, and so on, and all the options that you have chosen in that box. Okay, so I'm not going to go into that. Now you see a double line here. Okay, that double line means that it's the beginning of the results, and then it tells you that the first section of this report is for checking relay setting on a particular line, and the single dotted line here is the demarcation for the output for one end of the line. So we are looking at the Vermont end of the line right here. Okay, first of all, it tells you whether the program has decided not to check certain number of relays. Now, let's say they are signal only or they're looking backwards. We don't check them, so they will be listed here if they are there, and if there are some. Okay, and then the second section here says checking zone 1 of distance relay and instantaneous units of overcurrent relays. So in this case, I found that for a distance ground relay with this name, it reaches, it covers 61% of the line, okay? And there's an error because I told it that I want it to be between 80 and 90. So this is something that you should pay attention to. And then it decided to check the overcurrent ground relay that are there. And first, it didn't take any outages, and it found that it protects 33% of the line. We actually saw that graphically a minute ago. And also for the same relay, with the outage of one of the lines outage, the coverage didn't change much. It went to 35%. So because the error shows that what my preferences are, that these are not meeting. And then the relay checks zone 2, excuse me. Actually, for checking zone 2, let me go down here for the other end of the line. The reason being that at the other end, there are a lot more remote lines, so that it's more clear what it's doing. So here's beginning of checking zone 2. And now this relay, we are looking at a single relay on the study line. On the Oregon end, it tells you that right here. We're studying this part is for the Oregon end of the line. And there are 4 cases, and there are a bunch of cases that it checks, okay? One of the cases is for no outage of any kind. And the second case is for when they outage everything except the line that you're studying. And then the other 2 cases here are for the other remote lines. So from here to here, it's for a remote line R03. And from here to here is a study of the remote line 04. And from here to here is a study of the remote R05. You say, well, what are R3, 4, and 5? Well, all you have to do is go down here. It tells you what these are, okay? Excuse me, it's down over here. Basically, R is a nomenclature that means remote, and L means it's local. So this, we number them like this so to make it easier for us to not take too much real estate on the screen. And you can see that, let me just look at R3 here. You notice that with no outage, the zone 2 goes to and covers 5.9% of the remote line. Now it says that my limit is 15, so this is less. But if you don't care about this, put 0 in there, and this kind of command, this kind of check will go away. And then when I remove all the in-feeds, and usually this is when the zone 2 would go the farthest. So in this case, it went to 37. And then when I remove these other in-feeds one at a time, you can see that it varies the coverage of the zone 2 line. And it would usually increases from would be a number between the first one and the second one, the one with no outage and the one with all the other thing outaged. Okay, so in the program, there's a option for you to omit checking these two, because you know it's got to be between this number and this number anyway. So so it saves time, and if you so choose, you can tell the program not to do it. And so, yeah, so this is the result for zone 2 checking. So let me move on and now show you the other command. Okay, I'm going to still use the same line, but this time I'm going to right-click on any one relay groups. And by the way, you have to have relays on both ends for this second command to work, because this is the one that uses the step events to see whether your relays are working properly. And obviously, you have to have relays on both ends to isolate the relays, isolate the line. Otherwise, this won't make any sense. So, so here I say check relay coordination using step events. And I want to point out this box over here. This is really important because it lets you specify which kind of relays would be checked. For example, suppose you only care about ground relays and you don't want to exclude phase relays. You simply have to do is just pick this overturn phase out and the distance phase out. And so the program would simply check the ground relays without the phase stuff involved. So this gives you a lot of flexibility in checking. Right now, I just have everything checked. Communication schemes, voltage relay, differential relay, you name it, they're all over there. Okay, and these outage options are the same one as before, so I'm not going to show you. And also the checking parameters are the same. So when you're ready, press the OK button. And again, it will ask for a name of a file. So I just give it a name. And after a short time, it will give me a report. And it looks something like this, okay? So from here to here is the output for one of the events. And this is the event with the fault at 10%. It tells me that. See, here it's 10%. And it also has no outages. It's outage none over here. And then it will list you, give you this table. Each entry in the table is one event, okay? And so the first event is when you have the fault. Let me move this one a little bit. Okay, so at a certain time, some relay branch trip. Well, in this case, it's a problem, it's an error, because this relay that trip is on another line, not the line where the fault is. So that's bad. It says a branch opened before the study line is cleared. Now the second one is one of the two relays, the second event. Actually, one of the two relays actually tripped. But the CTI, it's so tiny, it's a 0.0865. In other words, there's another relay that's about to trip behind it that would have tripped in 0.08 seconds later. Okay, so this is definitely something you need to look into. And then the next two events are the same problem as the first one, namely that they are relays somewhere else and not on the line that's being studied. And then finally, the relay is the other end of the line tripped and isolating the fault. So that's the one of them. And let me go ahead and look for one. Okay, here's one that has an outage. So, and this one is a 10% also, but it has an outage of the Vermont to Minnesota line. And then you can see that it has a bunch of problems as well, because a couple of branches trip that they're not on the line. Basically, other things are tripping before the line is isolated. Now here's one that actually work more or less, because the relays on one end trip and then the relays on the other end trip. But the CTI is so puny that it's definitely something that you need to look at. Anyway, so this is the a kind of table you'll get from the step event analysis. So, and I think I am pretty close to my plan. So let me see. I'm bring back my PowerPoint slide here. Okay, so so you can see that we actually have most of everything working, but it's certainly like most things that things can get very complex when you have tap lines and other kind of things, and so we're going to be busy doing checking the command as well as writing up the documentation, so the testers who will be getting the program at first of the year would know what the options are. And so if you want to be one of the testers, please email me, and my email is schan@aspeninc.com. And I will open it up for questions and comments right now. I would take the mute off from all the participants. Okay, now you guys can talk, and I should be able to hear you. But before you talk, please tell us your name and also your company affiliation. Okay, any questions? Comments?
Hi, this is Kaustubh here from NIPSCO. You guys hear me?
Yes, loud and clear.
Yeah, so my first question would be, can we use this on a wide area scale, as in all the 138 kV systems or the 345 kV systems? The feature that you just showed.
The answer is yes. You notice that in the timeline that I mentioned that there will be a release of a batch checking command version on May 1st, so that would do exactly what you described.
Hello, this is Om Dahal from NIPSCO. I have one suggestion regarding in the report. Like in report, if there is error, then can we make the different font for the error, like red color for that error, so that we can easily visualize those errors and it will save our time. That's my suggestion.
The coloring, it's a good idea, but it's something that's very hard to do from a CSV report, because the CSV is a text report. We don't have all the powers of controlling colors. But I'll look into it if it can be done out there.
We can do it.
Pardon me?
So we cannot do this like we cannot color the report then.
Excuse me, I didn't understand what you just said.
I mean, there is no option for coloring the report here.
There's no option to what? Can you speak a little louder?
Yeah. Like there is no color option.
No power option.
No coloring option for the.
No coloring option. Yeah. As far as CSV file, there's no way that we can specify color. So far as no. Now, if you guys know that can be done, then we'll be happy to do it.
Okay, thank you.
But one thing is very easy to figure it out, because the errors on a certain column, the report. So if that column is blank, that means that there's no problem. So at least there's something that you can see very clearly if you train your eyes to look for that. And we're very conscientious about making the report consistent in format. So in other words, the errors are always on the same column, and the first columns are always blank except when starting a new relay, checking new relay, and so on. And so all those are tools that we put in there to help people that want to parse it on their own and do things further for processing of it.
I had another question. This is Kaustubh from NIPSCO again. While we do the settings for a relay, is it possible to take into consider all the outages, all the strong sources out, and give the apparent impedance that the relay sees? For instance, for a zone 2 relay, at 120% of the line, all the impedance that the relay sees, taking the sources out one at a time, rather than the fault currents in the report?
Yes, I understand what you're asking for exactly, and we don't have something that's exactly what you just asked right now, but we will plan on putting in something like that in the future version of the program.
Okay.
Actually, your question about the parent impedances and so on, those are very easy to find out using the phasor probe. And if you just take those outages and you can put the phasor probe at where you plan to put the relay, it will actually show you in case what the currents are and what the parent impedances are and so on.
Can you repeat that again? We couldn't follow.
Oh, okay. There's a command called a phasor probe. If I open my program again. Suppose that the location you want to put your relay, just do a control. You have to simulate a fall. So let's say I put a fall over here. I can do a control double click over here. I can show this is called a phasor probe, okay? And here's CA, ZBC, and CA are the parent impedances, okay? And you can also ask for the ground impedances. This is for the phase.
I don't know what it is and I don't care. I listen to the webinar.
Okay, so you can see that you can say, okay, I want to take this line out. You can take that out of service. You can do another call again. And let me just use a shortcut. Sorry. I click on this and it says, I put to another fault. And now I get a different set of impedance. And you follow? Okay, any other questions? Okay, well, it looks like I will say goodbye to all of you, and thank you very much for attending this webinar.